Okay, in this session, we are going to discuss about resonant circuits. We are going to classify resonant circuits as series resonance and parallel resonance. So first, we will discuss what is meant by resonant circuits. Why you have to study the resonance. The study of resonance is very useful, particularly in the field of communications. For example, the radio receiver has ability to select certain desired frequency transmitted by station. The radio receiver rejects all other unwanted frequencies transmitted by other stations. So, such selection of required frequency and rejection of unwanted frequency is really based on the principle of resonance. In general, resonance is defined as a phenomenon in which applied voltage and resulting current are in phase. So in other words, we are going to say an AC circuit is said to be in resonance if it exhibits unit power factor condition. That means applied voltage and resulting current are in phase. Thus, in an AC circuit, under the condition of resonance, the reactance gets cancelled if the inductive and capacitive reactances are in series, or the suspectance gets cancelled if the inductive and capacitive reactances are in parallel. So this is about the basic introduction about resonant. Okay, now we will see uh, quality factor, that is called as Q factor of resonant circuit, or other word for this one is called as figure of merit. So how to calculate quality factor or figure of merit of a resonant circuit? We'll see. The resonance phenomenon is observed in AC circuits consisting of reactive elements such as inductor and capacitor. These two elements are basic passive elements of energy storing type. We may know inductor and capacitors are what? Passive elements of energy storing type. It is also found that comparing with various inductors and capacitors in terms of efficiency, while designing such circuits, efficiency measured as a quality factor. So efficiency of a what? Any circuits is measured in terms of quality factors. So how to define quality factor or figure of merit? So the notation for representing quality factor is Q. Q equal to 2 pi into maximum energy stored per cycle divided by energy dissipated per cycle. So this way we are going to calculate what quality factor or figure of merit for the uh, given circuits. See here, I'm going to sketch one simple circuit. Uh, Supply voltage is there, that is connected in series with resistor and in a series with inductor. So this is plus minus polarity. This is resistor R, this is inductor L. And one more circuit I'm going to assume, consider, that is resistor in series with capacitor. So resistor in series with capacitor. Okay, this is resistor, this is capacitor. Now through this circuit, current I is flowing. Similar here also, current I is flowing. So what we consider here, we consider two circuits. First circuit, the resistor in series with inductor. In the circuit, in the second circuit, the resistor in series with capacitor. Okay, this is what voltage is applied to an inductor with leakage resistance in series. Similarly, capacitor in series with resistor. So let us calculate maximum energy stored per cycle. Now we are going to calculate maximum energy stored per cycle as work done. W equal to 1 by 2 L Im square. What is Im? Im stands for what? It is the peak. Or we can say M stands for peak means maximum. Maximum value of current. Maximum value of current. So M stands for maximum, or we can say peak current. So work done equal to what? Across this circuit, WL equal to 1 by 2 L inductor multiplied by maximum current square. Similarly, average power dissipated in this circuit, that is represented by P. Average power dissipated in inductor is given by P equal to power IRMS square multiplied by R. So what is the IRMS? It is maximum current divided by square root of 2. IRMS equal to what? It is maximum current divided by square root of 2 square multiplied by R as it is. Let us do the simplification. Square of 1 by 2 square root, it becomes 1 by 2 and multiplied by what? Im square into R. Okay. So we calculated power, that is 1 by 2 Im square into R. Fine. Now move on to the next. That is total energy dissipated. So what we are calculating? We are calculating quality factor for the circuit. So quality factor equal to what? Already we discussed. Quality factor is what? It is the ratio of what? 2 pi multiplied by maximum energy stored per cycle divided by energy dissipated. So energy dissipated. So first we have to calculate maximum energy stored as well as dissipated. So total energy dissipated per cycle. So how to calculate? Energy dissipated per cycle is equal to power by F. So simplify. For the simplification, already we calculated P. P is what? 1 by 2 Im square into R divided by F. What is F? What is F? F is a what? It is a frequency of operation. Frequency of operation. So now quality factor of inductor is going to calculate as quality factor of inductor is going to calculate as per the formula 2 pi multiplied by what is the formula? Once again I'm going to refer the formula. Maximum energy stored divided by dissipated. Maximum energy stored divided by dissipated. Maximum energy stored is how much? That is already we calculated. This is 1 by 2. The maximum, this indicates maximum energy stored per cycle. This one already we calculated. Okay. So maximum energy stored per cycle divided by energy dissipated. Dissipated here we calculated. So how much? It is energy dissipated. Now I am going to substitute the formula. So quality factor is equal to 1 by 2 into L into Im square divided by 1 by 2 Im square into R divided by F. Do the simplification. This and this get cancels. 1 by 2, 1 by 2 get cancels. Then F will go to the numerator. Okay. Is it correct? So is equal to F will go to the numerator. It becomes 2 pi F. And left with what? L left with what? In the denominator R. So we can write quality factor Q equal to 2 pi f into L by R. So what is 2 pi f? 2 pi f we can write omega W, WL divided by R. Hence, this is the formula for calculating quality factor of resonant circuits. Q equal to omega L by R. So I am going to represent this as a equation 2. Before this one, this equation we got because of this formula. So I am going to represent it as equation 1. Is it clear? So what we calculated, this is the formula Q equal to what? Quality factor of what? Resistor is with inductor. Similarly, for a second circuit, if you are going to calculate quality factor, how to calculate? Now go for second circuit. In the second circuit, voltage V is applied to a capacitor. So now for the second circuit, nothing but R in series with C. Okay. Now first write maximum energy stored per cycle. Maximum energy stored per cycle. That is WC equal to 1 by 2 C into Vm square. W is equal to 1 by 2 C into Vm square. Okay, before discussing what Vm stands for, as in the previous case, IM stands for maximum current or peak current. Here also Vm stands for peak or maximum value of applied voltage. Maximum value of applied voltage. Now, in the formula, Vm stands for what? Vm equal to what? Tell me. Before that, one more parameter I'm going to write. Xc equal to reactance, capacitive reactance is equal to 1 divided by omega C. This is what? Capacitive reactance. Capacitive reactance. Now, the equation becomes Wc equal to 1 by 2 C Im divided by Wc square, that is equal to 1 by 2 simplification Im square divided by W square C square. Is it correct? This is a simple simplification, mathematical simplification. Now move on to the average power dissipated. This is energy stored, maximum energy stored per cycle, this one. Now move on to the calculation of the average power dissipated in capacitor. So that is given by PD dissipation. D stands for dissipation. Im divided by square root of 2 square, same thing, multiplied by R. So Im square divided by 2 into R. Now as for the formula, energy dissipated, this is power dissipated, but we want energy dissipated. So energy dissipated equal to PD divided by F. PD is what? 1 by 2 Im square into R divided by F. So both the things we calculated this one, maximum energy stored we calculated, say this one, equation number 3, and we calculated energy dissipated, equation number 4. Now substitute equation 3 and 4 in equation 1, then it becomes it becomes Q equal to 2 pi into maximum energy stored, that is 1 by 2 Im square divided by omega square C whole divided by, is it that? You can refer equation 3 and 4. After referring equation 3 and 4, you are getting like this. Next, energy dissipated 1 by 2 Im square into R divided by F. Now, further simplification, 1 by 2 get cancels, Im square get cancels. F will go to the numerator, it becomes 2 pi F. Okay. Next, what is that? 1 divided by omega square into R, omega square into R into C. Okay. Now, for the simplification, Q equal to 2 pi F. This one is nothing but what we can write. Okay, 2 pi F is nothing but what? Omega. So let us substitute here. That is Q equal to omega into 1 by omega square into RC. 1 omega and here square get cancels. So left with what? 1 divided by omega RC, WRC. Hence quality factor for resistor in series with capacitor, we are going to write it as 1 divided by W into R into C. This is the equation number 5. Likewise, we are going to calculate quality factor for resistor in series with the inductor, resistor in series with capacitor. This is the basic thing of calculation of quality factor or figure of merit. In the next section, we are going to discuss about